Hello viewers, I'm Kausalya. Today we are going to solve problems related with RC transients. The problem is a resistor is connected across the terminals of a 20 microfarad capacitor which has been previously charged to a potential difference of 500 volt. So initially the capacitor voltage is 500 volt and the capacitance value is 20 microfarad. If the potential difference falls to 300 volt in zero point 0.5 minutes, right? If the voltage across the capacitor reduces to 300 volt in 0.5 minutes, okay, the time taken to reduce from 500 volt to 300 volt is 0.5 minutes. Calculate the resistance in mega ohm. So here this is the given network. So we are asked to calculate the value of resistance, right? So here in this case, you see, initially the capacitor is charged to 500 volt and then the value of 500 volt reduces to 300 volt. So what do you mean by this? So in this case, the capacitor is discharging, right? So this scenario is the discharging of the capacitor, and the expression for voltage across the capacitor is given by E into e to the power minus t by lambda, right? So here in this case the voltage across the capacitor is 300 volt, right? The voltage across the capacitor is, initially it is 500, that is capital E, right? Now it is reduced to 300 volt. So here the maximum limit up to which a capacitor can get charged is always equal to your supply voltage. So that's the reason why here the 500 volt is taken as capital E. And the time duration is 0.5 minutes, which is nothing but 30 seconds, right? 0.5 minutes is, that is 1 minute is equal to 60 seconds. Therefore 0.5 minute is 30 seconds. And the value of capacitance is 20 microfarad, right? So here EC is equal to E into e to the power minus t by lambda. We know the value of EC, we know the value of capital E, right? So into e to the power minus t by lambda here. So when you solve, right, when you take ln on both sides, this exponential term decreases. Therefore, ln of 0.6 is equal to minus t by lambda. So here in this case, we are expected to calculate the value of R. So lambda is nothing but our time constant, right? So which is nothing but RC. So initially we are calculating the value of lambda. So lambda is nothing but minus t by ln of 0.6. So here t is nothing but 30 seconds. So 30 divided by ln of 0.6. So when you solve here, the value of lambda is 58.728. So as we all know, lambda is nothing but our time constant. So here the value is RC. So therefore, the value of R is nothing but 58.728 by C, and the value of C is given in the problem. So 20 microfarad. So once you solve this expression, the value of R is calculated as 2.936 mega ohms. Right. We proceed with problem number 2, and here the problem is the 20 microfarad capacitor in the circuit has an initial charge Q0 of 0.001 coulombs as shown. The switch is closed at t equal to 0. Find the transient current. Right. So here this is the given circuit diagram. It has a DC voltage source. We are having a resistor and a capacitor in series. And here the initial charge on the capacitor is, it is given here, right? So here we are asked to calculate the value of transient current. Okay, the current that flows at the instant when the switch is closed. Okay, that is known as transient current. So here you see, since there is an initial charge, we are going to calculate the initial voltage, right? So initial voltage across the capacitor is given by Q0 by C. We know the value of Q0, we know the value of C. So just substitute the values, and here the initial voltage is 50 volt, right? Now we are proceeding with writing differential equation for this circuit. So in this case, the current flowing through this circuit is I. Therefore, 100I plus 1 by C integral of I into dt. right, which is equal to, that is sum of voltage drop is equal to sum of voltage rise by KVL, right? So here in this case, you see there is a voltage source of 50 volt and initial voltage across the capacitor is 50 volt, right? Therefore, which is equal to 50 plus 50 here. Now once you start to solve, you see here the final expression holds like this. Okay, 100i plus 1 by c integral of I into dt, which is equal to 100. Now the next thing is we are asked to calculate the value of current, right? So you see the general expression for calculating the current is, okay, when you have this kind of expression, the solution for this general expression is given by I of t is equal to E by R into e to the power minus t by RC. Right. So here in this case, you can directly substitute, you can make use of this formula directly and substitute the values from the problem. Okay. The solution will be quite simpler. So in this case, when you substitute, you see when the value of E is, it is nothing but 100 and the value of R is again 100, and here we know the values of R and C. Okay. All the parameters are given. So when you substitute here, you see the value of I of t is given as e to the power minus 500t. Right. This is one way of framing solution. Or you can take this equation, again you can apply Laplace transformation and you can proceed in a normal way. That is how we solve our derivations. So here in this case, you see I had taken Laplace transformation for the equation, right? So in this Laplace transformation, again I had taken I of s commonly outside. So the value of I of s is given by just by moving this part. Okay, when you move it down, you see here we are having an expression like this. Right, here we are having this and I am multiplying this expression with the s here. Then again here you see, here we are having an, that is again by simplifying we are having an expression like this. So finally the value of I of s is given by 1 divided by s plus 500, right? So again when we always need I of t, because I of t is means transient current. So when you take inverse Laplace transformation, here we are again ending up with the same answer, I of t is equal to e to the power minus 500t. So here in this method, I had shown two different ways of solving a problem. So according to me, the best thing is you just memorize the final expression for an RC circuit or an RL circuit. When you know the final expression clearly, then you can just substitute the values and you can end up with finding the solution. Or else you see we are going, that is taking Laplace transformation and again taking inverse Laplace transformation, it takes lot of time. Right. So rather than going with this, it's simple to remember the formulas, to remember the final expression. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.